Hey class, Mrs. Anderson here. Today we're going to learn how to write the equations of a piecewise function. And yesterday we graphed the piecewise functions. So today we're going to look at the picture and then come up with the equations. So by the end, I hope that you can write the equation and identify key features from the graph. So we do need to go over just a little bit of vocabulary first. First, remember slope-intercept form, that is our y equals mx plus b. And remember that m stands for slope, and we find that from our graph by looking at our rise over run. And then b stands for our y-intercept, and that's where it crosses the y-axis. And then point slope form might be new to you, or you've maybe seen it before, but this is y minus y1 equals m times x minus x sub 1. And we use this when we can't identify these y-intercept clearly. So m is still the slope of the line, and then you have x1 and y1, and that is any point on the line. And then x and y, like this x and y and this x and y, are the standard x and y in the linear equation. The other variables are variables that we'll plug into. Okay, so here's our first example. Write the equation of the piecewise function. So just like when we graphed it in two pieces. We're going to write the equation in two pieces and then put it back together when we're done. So I'm going to split this in half. And then I need to decide, where does my domain split at? Where does my graph split? So if I look at this graph, I can see right here, this is where my lines go different directions. So I have a domain split at -1. So I'm going to have to come up with an equation for y equals for this left and the right. And for the left side here, this line is a closed circle there, and it's going to the left. So it's going to be y equals when x is less than or equal to -1. Because I'm going to the left of -1, so less than, and it's a closed circle, so I have the equal to. And then I'm going to need a y equals equation on the right for the other line, and that's going to be y equals some line when x is greater than -1. It's an open circle, so there we have just greater than. Okay, the first thing I'm going to do is try to identify my slope and my y-intercept. And if I can do that, then I can plug right back into slope-intercept form. So I'm going to do the left side first, and I can pick 2 points on my line and then find the rise over the run to find the slope. So this is a rise of +1 and a run of +3. So my slope for this line will be 1/3. Now my y-intercept is where it crosses the y-axis, which is the vertical axis. And if I go and I continue my slope up 1/3, and then I connect those two dots, I can see that my y-intercept will be right here. But that is not a clear point. And so I'm not able to use slope-intercept form. I will have to use point slope form, which means I will need to pick another point on that line. So I'm going to get rid of some of my marks here so we can see it a little bit more clearly. So I'm going to need a point, x1, y1 point. I'm going to just choose this point right here, and that's -1, -1. And then I'm going to plug that into point slope form, which the equation is y minus y1 equals m times x minus x sub 1. So I'm going to replace the slope with the 1/3, and then I'm going to replace the x1 and y1 with the point -1, -1. So those two, I'm going to replace those two. So substituting in, I have y minus -1 minus a -1 will be +1 equals, slope is 1/3 times x minus -1, and that'll be x plus 1. And now I can just simplify this and solve for y to get it into slope-intercept form. I'm going to do that first by distributing the 1/3. So I'm going to have y plus 1 equals 1/3 x, and then 1/3 times 1 is 1/3. And the last step will be to subtract 1 from both sides. And my final answer will be y equals 1/3 x. 1/3 minus 1 will be -2/3. So that is my equation for this left side. 1/3 x minus 2/3. For x is less than or equal to 1, -1. For the right side, I'm going to identify my slope. I could go back here and put my -2/3 was my y-intercept that I found when I rewrote it. So I'm going to identify my slope and my y-intercept for the right side now. So picking 2 points on the graph to identify the slope, I'm going to go rise over run. So here I go down 1 and then right 1. So I have a slope of -1 over 1 or a slope of -1. And then the y-intercept here is given at +1. So I have a y-intercept of 1. So this one I can plug right into mx plus b, and it'll be y equals -1x plus 1 when x is greater than -1. So now I have my 2 pieces for my piecewise function. So I just need to write it in piecewise function form, which looks like this. That'll be f of x equals, and then you make a bracket, and you have 1/3 x minus 2/3 if x is less than or equal to -1. And then we have -1x plus 1 if x is greater than -1. And that will be our final answer. Hopefully you found some room for that. I kind of ran out of room up here, so the idea is to once put it back together. Okay, let's try another one. I'm going to erase this so that I have a little bit more room to work with here. So the first thing I'm going to do is split this in half, and I want a y equals and a y equals, and then my domain is split here at, this time it's at x equals +1, and to the left has the open circle, so that'll be x is less than +1, and going to the right has the closed circle, so it'll be greater than or equal to +1 there. And then I want to try to identify my slope and my y-intercept of each. So starting with the open circle, going this way, I'm going to try to identify the slope here. I'm going to have to erase that so I can see it a little bit better. But let's see, down 2, left 2, so down 2, left 2, so -2 over 2, which would just be positive slope of 1. And then my y-intercept is at 1, 2, 3, -4. So that's nice that I can just rewrite this one in slope-intercept form right away. 1x minus 4. Let's look at the other line. I have a slope of +3 up 3 right 1, so +3 over +1 will be a slope of 3. Let's see if I can identify my y-intercept. I'm just going to continue graphing this line, kind of going backwards. So if I go down 3, left 1, I could connect this line, and it does have a y-intercept, and the y-intercept's right at 0. So I can plug right back into slope-intercept form again. It'll be 3x plus 0, which is just 3x. So that one was a little bit easier than our first example. So writing that back into slope-intercept form, or I mean piecewise function form, we do f of x equals, we make our bracket, then we do our first equation is 1x minus 4 if x is less than 1, and 3x if x is greater than or equal to 1. And that would be our final answer for that example. Okay, let's do one more with the video here, and then we'll save one for when we're all back together in class. All right, so we're going to split this one up. We have y equals and y equals, and then it looks like my domain splits at -1 again. It's not going to be -1 and 1 every time. The examples that I've chose just apparently are -1 and 1. When I go to the left of -1, which would be less than, it has an open circle. So this first one here will be x is less than -1. And when I go to the right, it has the closed circle, so that'll be x is greater than or equal to -1. And then I want to try to identify my slope and my y-intercept of each line. Let's start with the, let's start with the horizontal line, because horizontal lines, this one to the right, we know that horizontal lines have a slope of 0. There is no rise. So it's 0 over anything is always 0. And then the y-intercept is at -1 is where it crosses. So when you plug it into mx plus b and you have 0x plus -1, it's just y equals -1. So that's a horizontal line, y equals -1. Okay, how about the other line? So let's look for the slope first. So I'm going to identify 2 points on the line and then find the rise. So we got +3 over +2. So I got a slope of 3 over 2. So let's continue the graph and see up 3 over 2. I do not know what this point is. So we're going to have to use our point slope form, which is y minus y1 equals m times x minus x1. And then the slope is going to be 3/2, and x1, y1 will be any point on that line. So I will pick the point, let's see, how about -3, 0? -3, 0 is a point on the line. That's a good point to use because it has a 0 in it. So sometimes that's easier. So this is x1, this will be, oops, the second one will be y1. Okay, so plugging those in to our equation, I will have y minus y1, so y minus 0 equals m is 3/2 times x minus x1. So x minus -3 will be x plus 3. You minus a negative, it equals a positive. So then you have y equals 3/2 x plus 3. And then we just need to distribute, and we'll get y equals 3/2 times x plus, remember when we did the fraction times a whole number, we put the whole number over 1, and then remember my song, top times top over bottom times bottom, so you'll get 9 over 2. And that is our equation for that side. So we got 3/2 x plus 9 over 2. So now we can write our piecewise function, f of x, include our brackets, and we'll get 3/2 x plus 9/2 if x is less than -1. And then we have just y equals -1 if x is greater than or equal to -1. So I forgot to write the word if, but you can use a semicolon instead of if you want instead. So that's my semicolon in between. Okay, the three piecewise, we will save till we're back together in person, and we will do that one together. I hope you guys have a great rest of your day. Thanks for watching.